In this section, we will set the physics conditions that govern our analysis. So first, we'll assign the proper materials. So we'll go back to Simulation Process and open the Physics menu. And under Material Assignments, we see that there's already a default structural steel assignment to both the sign and the post. We will leave the structural steel as the material, but under location, instead of having it be the structural physics region, we will choose just the post. But according to the problem description, we need to alter the properties of the default structural steel material. So we can click on structural steel and go down to the isotropic elasticity and change Young's modulus to 3 e to the 7 psi and Poisson's ratio to 0. And now we can go back to physics and we'll add a new material assignment. This time, choose the sign and the application surface as our location, and under material, we can choose create new. So for the name, we'll call it massless steel, and we need to add properties. So first we'll add a density. And we'll put 1 e to the negative 30 pounds per foot cubed. And then we can also add an isotropic elasticity. And we'll use the same values for Young's modulus and Poisson's ratio as the modified structural steel. Now we will add the structural conditions. And first we'll add the force depicted as Fy1 in the original problem descriptions. So we'll go back to physics, structural conditions, and add a force. We first want to select apply remotely from originating point. And then if we center the geometry, for our location, we will choose the face of the sign. And then we'll change define by to directional components, and in the y component, we will give it an 8,000 pound force. And we can also rename the force to be Fy1 so it matches the problem description. And next we'll add the force that's pushing down on the top face of the sign, so on this face right here. So we'll create a new force, and we'll name it WZ1, and for the location, we will choose that top face of the sign. And again, we'll change define by to directional components, and in the Z component, we will put negative 11,700 pound force. Then we need to add a pressure incident on the application surface, so this surface here. And so we'll go back to physics, go to structural conditions, add pressure. And for the location, we'll choose that surface. And for the value of the pressure, we will write 34.722 psi. And this will be a uniform pressure and will apply the maximum pressure along the surface, instead of having it to be spatially varying in the z direction as it was in the problem description. So we'll rename it to be WX2, and we'll go back to physics and add Earth's gravity. So we'll need an inertial load. And in the z direction, we'll change it to -1 gravity. And now finally, the last thing we need is a support. So in the problem description, the bottom of the post is the location for the fixed support. And now we're all set to solve.